Okay, so let's revisit question number one. I know a lot of people want to practice looking at the actual roots and finding the factor, but remember on the last video, that's one of the last things we did. Nonetheless, because I know that's what you want to see, I'll go ahead and do that again. If this is the root, -2, what is your factor? X plus 2. Remember, you're going to have to change the sign. Here, if my root is 4, what was the factor? X minus 4. And I know you're probably wondering why. Let's revisit that. If x plus 2 is the factor, you would have subtracted 2 and got -2. So if you start with -2, then your factor would be x plus 2. X minus 4 is your factor. Set that equal to 0. Add 4 to both sides. X is what? 4. So if you start with 4, x minus 4 would be your factor. Now, is there anything else we need to talk about before we start writing the vertex form of a quadratic equation? Real quick, let's just review how we know that x equals 1 is the axis of symmetry. You can look to see if the distance from the axis of symmetry to the root or roots are the same. So I'm going to count 1, 2, 3, yay. Count again, 1, 2, 3, yay. And so that I see now what? That this distance is the same as what? That's what they call equidistant from the axis of symmetry, and that would be the roots that we are referring to. And you look down here, I notice that the y-intercept is 1 away from the axis of symmetry. So this point here must also be 1 away. And that point is what we're going to use today, which is 2, -8, when writing the vertex form of the quadratic equation that represents this parabola. Now, be mindful that 2, -8 is the point we're going to use. 1, -9 is the vertex. Now, something we need to talk about. We've used x and y because we were talking about vertical lines and horizontal lines. So you needed to know that x equals 1 and y equals negative. Oh, excuse me. And y equals -9. So this time we're going to use h and k. Why is that? We're not going to use x and y because I need to use x and y for the point. And I have to get you ready for Algebra 2. And in Algebra 2, the vertex is referred to as h and k. Now, we're coming out of Algebra 1, guys, into Algebra 2. So, you should already know that x equals 1 is the axis of symmetry. And that's a vertical line. Y equals -9 is a horizontal line. Now that we know that wherever they intersect, that is the point. We can now move away from using x and y on the vertex and use h and k. But we have to use x and y on the point because anytime you have an equation that uses x and y, if you take a point from the graph, that point has an x and y, and it can be plugged into the equation. Got it? Now, let's go ahead and plug all this information in. This is your x value. And I'm plugging it in. Good. This is your y value. And I'm doing what? Plugging it in. Good. Now, this is my x. No, it's my h now. Oh, so that's why we went ahead and plugged in our x and our y. Now the h is 1, and you notice how I left the minus sign? Because my h was positive. Now had I had a negative 1, this would have become plus 1. So I just put a 1 here and brought down the minus sign. Now let's put in negative 9. And this one, it changes to minus 9. So your k value will match exactly what you see in your vertex. But your h value is always going to be the opposite, like when we did transformations. Okay, so let's solve now. We have to find the value of a. Let's review real quick, actually, before I solve for a. Oh my. Uh-oh, lost some lead there. Okay. So, plug in the vertex. The vertex is 1, negative 9. Look, 1, negative 9, h and k. The point is 2, negative 8. 2, negative 8. Now find the value of a. Okay, so this is not hard. 2 minus 1 is 1. Square that, and you get what? 1. Then 1a. Bring down your minus 9. Bring down your negative 8. And do what with your 9? Add 9 to both sides. Then what do? Well, this is 1. Bring down your 1a. Now, please don't try to divide by 1. It's the same thing as just a. So now we know that a is what? 1. We can do what with it? Plug it in. Let's take that a value, put it right here in the a spot. And then x minus 1, close parentheses, squared minus 9 is the vertex form of the equation. Now, how did we get that? We plugged in the value of a, we plugged in h, we plugged in k. So, let's see if you can pick out the vertex. Looking at the vertex form of the equation, what would it be? Positive 1, negative 9, or negative 1, negative 9? Positive 1, negative 9, because it's always going to be the opposite for the x, or the number that's inside of the parentheses with the x, which is what we call the what now? The h. So this is h, and this is k. Okay, so now that we know that a is 1, let's go ahead and take that a value and put it in front of the parentheses that hold the factors. Look, there are the factors. And what did I do? Put in the value of a. Ta-da! Isn't that beautiful? So now we have the factored form and the vertex form. Pretty cool, right? Now, whether you believe it or not, those forms will both graph the same parabola. So I will get this one graph from this standard form, from this vertex form, and then from this factored form. But not only that, I can multiply this out I can multiply and then add and subtract. And what will I get at the end? The standard form from both of those. Well, let's go through that real quick. X minus 1 squared is the same thing as x minus 1 times x minus 1. Then we put minus 9 at the end. So this is x times x, which is x squared. X times negative 1, that's minus 1x. Negative 1 times x, that's minus 1x. That's how we get what? Minus 2x. And then negative 1 times negative 1 is plus 1. Now you could multiply by 1, but it doesn't change anything, so it really just disappears. Bring down negative 9, and that's 1 minus 9, because they're like terms. These are the only two that can come together. So that's x squared minus 2x minus 8. And I went from vertex to what? Standard form. Very simple. Let's come over here. X squared plus 2, x minus 4 with an a value of 1. So these are my factors. This is the factored form. Now let's double distribute. You can use the box. X times x is x squared. X times negative 4 is negative 4x. 2x is what you get when you multiply 2 and x. And then 2 times negative 4 is negative 8. So now combine these terms in the middle, and we're not going to multiply by 1, because it's not going to change anything. So combine my terms that are alike, which would be these two. That gives me negative 2x, and bring everything else down. Look, standard form. Standard form. They're both in standard form of quadratic equation. And then look at my vertex. Look at my factor form. All three of these forms give you this same graph. They will all give you a vertex of 1, negative 9. They will all give you roots, negative 2, 4. They're just different forms of the same parabola, or the same equation, I guess you could say it that way. I want to be grammatically correct, but I don't want to overspeak you. And I know a lot of times math teachers speak math language and you don't get it. So let me see if I can help you understand. Like Bumblebee. He's still Bumblebee, even when he's the car. He just transforms into a different shape. But he only comes in two forms. The quadratic equations come in 3. So vertex form, factor form, standard form. And remember, all of these forms represent quadratic equations. So the largest exponent you should see is 2. And I see it there, and I see it here, but I don't see it there. But remember, it shows up when you multiply it out. Now, let's come down here. Y equals x minus 1 quantity squared minus 9. This is your vertex form. What do we know? That the a value is 1. It's positive, so this is a minimum. The vertex would be 1, negative 9. Always change this value. The axis of symmetry would be 1 because that's this number. It's always the first number inside the parentheses of the vertex. The minimum value is negative 9. And we know this is a minimum. Why? Because a is positive. Let's look here. X plus 2 and x minus 4. This would be your factored form. So x plus 2 gives you a root or 0, x-intercept or solution of negative 2. And then x minus 4 gives you a solution of 4. You can write that in set notation. So negative 2 comma 4. Which means negative 2 comma 0 belongs to this one here, and then 4, 0 belongs to that one there. So you can write them, I like to refer to these as squiggly brackets, as one of my friends, teacher friends from a couple of years ago used to say. So you can write both roots in squiggly brackets or in parentheses, but you have to separate them when they're in parentheses versus when they're in a squiggly brackets, you write them together. So be careful about that. The axis of symmetry is still 1. How did I get that? I just took my roots added them together, and divided by 2 to find the middle, which is 1. See? Or you could count 1, 2, 3, 1, 2, 3. Now that I have my roots and solutions, and I know where my axis of symmetry is, you can find the vertex by plugging in the 1 into your factored form. So I put my 1 here. 1 plus 2 is 3. 1 minus 4 is -3. So 3 times -3 is -9. So you don't necessarily have to plug that into the equation like we did here, the standard form of the equation. See how I plugged in the 1 there and still got my -9 as I did here? You could plug it into the factored form or the standard form of the equation. Don't forget, you can also use x equals -b over 2a to get the axis of symmetry, as well as just add the roots together, divide by 2, and get the axis of symmetry. One last thing, that C value is your y-intercept. Awesome sauce. I will stop this video and start the next one. We will review another problem similar to what we just did, and then I'll show you the homework.